Here we see a list of several properties of vectors. Let's say that U, V, and W are vectors. C and D are scalars. Remember, we're thinking of those as constants. And then we have the following. Vector V plus W is the same as vector W plus V. The order doesn't matter. That means addition of vectors is commutative. If you're adding three vectors, you can group the first two and then add the third one, or group the last two and add the first one. That tells us that vector addition is associative. When you add a zero vector to a vector, you just get the original vector. That is the identity property. If you add a vector and its opposite, it takes you back to zero. This is the additive inverse property. And by the way, this was additive identity as well. Then moving on here, you see your C's and D's coming onto the scene. If you are multiplying a sum times a scalar, you can distribute. So we see the distributive property works with vectors. And here we just see similarly, if you've got instead of two vectors, two scalars, also works distributively as well. Here we see a regrouping in multiplication, so we see associative at work again. Please notice that this is involving scalars and not the product of two vectors. And here we see 1 times a vector is itself. That's the multiplicative identity property. 0 times a vector is going to be the zero vector, okay? And a constant times the zero vector is just 0. Number 11 has this symbol introduced. When you see this, this is talking about the magnitude of vector V. And that just means the length of it, okay? So when you've got C times, if you've got a scalar multiplying a vector, you can either multiply it inside or outside and afterwards. So this looks a little bit like absolute values, but doubled. So when you see those double bars, you'll know that that means the magnitude of the vector. So let's talk about what it means to be a unit vector. So a unit vector is a vector that has a magnitude of 1 unit. So remember, magnitude means length, okay? This is an important underlying concept in some things that you will study later in school. If vector V is the vector AB, so this implies that it is in standard position and that this is its terminal point, then a unit vector U sub V in the direction of V is given by unit vector V is equal to 1 over the magnitude of vector V times vector V. You can express that in component form there and then multiply it out. Now, I think that sounds a little vague until you actually see what's going on. So let's say we want to find a unit vector in the direction of this vector here, vector W. So vector W has a terminating point at -3, 2, as you can see here. What we would be interested in doing is finding a vector of length 1, let's just say that's 1, that's in the same direction that W is in. Okay, well, if I want it to have a length of 1, then I need to find out this total length and multiply by 1 over that. So like if it was 5, I would want to multiply by 1/5. If it was 12, I would want to multiply by 1/4. So how do you find the magnitude of a vector? The magnitude of a vector is the square root of a squared plus b squared. And think about why this is. Here's -3, here's 2. Well, -3 is just the x distance. We're going to square it, so it's going to turn positive. The b, that's 2 is the y distance. We're going to square it. That's how you find the magnitude. So we're doing W, so let me rename it. It doesn't matter what we name it. But the square root of a squared plus b squared is square root of 13. So that's the length of the whole thing. So I want to, if I'm finding a unit vector, then I want to multiply by 1 over the square root of 13 times my original vector, because I want it to go in the same direction. I just want it to have a length of 1. So when I multiply by this scalar, I get negative 3 over the square root of 13, 2 over the square root of 13. But because somebody somewhere didn't like radicals in the denominator, we will rationalize. And we get this result for our unit vector. Okay, so this would be the vector here, this unit vector, in the same direction as W with a length of 1. Let's try another one. So we want to find a unit vector in the direction of V. Well, first thing we need is the magnitude. So the magnitude of V is the square root of 5 squared plus negative 1 squared, which is the square root of 26. So I'll multiply 1 over square root of 26 times the vector 5, negative 1. And I'll have 5 over the square root of 26, negative 1 over the square root of 26, which when rationalized is 5 square root of 26 over 26, negative square root of 26 over 26.